So with that, we move on to our next session, which is going to be again a very interesting and exclusive session, especially curated for you. We move on to the second last session of the day, subjected around modernization of railway infrastructure. As the moderator for this session, I would like to invite Shri Anirudh Kumar, Senior Vice President, Kalpatru Projects International Limited. Welcome, sir. Inviting our speakers, Shri Udayveer Singh, Executive Vice President, FCONS Infrastructure Limited. Shri Veer Narayan, Vice President, Projects and Head Operations, Railways Tata Projects Limited. Shri S.C. Gupta, Vice President and Head, Proposal and Tendering, L&T Construction. Shri Anirudh Kumar, Senior Vice President, Kalpatru Projects International Limited again. Shri Shaunak Mitra, Head Codes and Approval, Fastening, Hilti India Private Limited. Shri Gulzar Miglani, Managing Director, Voslo India. I now hand over to our moderator to please take the session further. Over to you, sir.
So, good afternoon, everyone. So, we are already late by 45 minutes, even more than 45 minutes. So, I would like to conclude this session, try to complete in next 30 minutes. So, I will request my own co-panelists also that they will focus on the main agenda, and in brief they will express their views. So the topic of this session is modernization of railway infrastructure. So since morning we were talking about the rolling stocks, movable part of the railway component. So now it's about the fixed asset, which is basically railway tracks, bridges, formations. So my co-panelists are Mr. Guljar, Mr. Udayveer Singh. He is Executive Vice President. No, he is not there. Okay, okay, yeah. So first, I will just give my presentation. So, I am representing Kalpatru Projects International Limited, which is one of the largest integrated EPC company. And we have mainly, we are present to power transmission and distribution, buildings and factories, water infrastructure, railways and metro, oil and gas, and urban infra. And our company is around 4-decade-old company. We have a footprint in more than 73 countries. And our turnover is 2.4 billion US dollar, or equivalent to 20,000 crore rupees. And we have an order book of around 7 billion US dollar, that is equivalent to around 57,000 crore. And we have a 10,000 plus employees. So about the railway portfolio, we have till date we have commissioned around 8,800 track kilometer of the railway electrification. And we have done 750 track kilometer of the track laying and the track laying work. And our main business we are doing basically civil track electrification signaling. And our key clients are Arvinel, Core, and Konkan, and MP Metro, and other. So now coming to this Indian Railway future. So Indian Railway network, which is the fourth largest in the world after USA having 2.5 lakh kilometer, China 1.24 lakh kilometer, Russia 86,000. So Indian Railway network, which is around 68,000 route kilometer, or if we talk about the track kilometer, it is 1,27,000. So Indian Railway has come in a long way since inception, and it has progressed. And till date, we have done around 95, 96% of the railway electrification, which is the highest done by any country. Because if you see this electrification, in the European EU, only 56% track are electrified. In UK, 38% electrification is done. And in US and Switzerland, only 1% electrification is done. And last year, we have done 7,188 kilometers of the track electrification. And by next year, we will complete the 100% electrification. And this Indian Railway vision extends beyond the bullet trains. We right now, around 82 Vande Bharat trains are under operation. And we have a vision that 4,500 Vande Bharat trains will be under operation by 2047. So under the Amrit Bharat scheme, we are basically doing the redevelopment of the stations. 1,309 railway stations had to be redeveloped. But if you will see the progress, what we have done in last 10 years, if you will see in 2013-14, the gross budget for the railway was 28,000 crore, which has increased to last year 2,40,200 crore. And the same way, in the morning, all this earlier speakers, they said that freight loading. So the freight loading in 2013 and 14, it was around 1 billion tons, which has increased to 1.5, 1.6 billion tons. And we have a target in next 5 years to 3 billion tons. New track laying, which till 2013-14, we were doing a 4.27 kilometer per day, or 1,562 kilometer in a year. So last year we have done a 14.5 kilometer per day and 1,500, and we have a target of next 5 years, 40,000 kilometer of new tracks. So the average is coming around 8,000 kilometer per year, or you can say 22 kilometer per day. So now you can see that we have to enhance the capability, and we have plenty of opportunity in the future in the railway segment. So if we talk about this opportunities, so recently the government, Indian Railway, they have identified that 3 economic railway corridors, mainly energy, mineral and cement, that is for the minerals corridor, that is 192 projects shall be coming. For port connectivity corridors, 42 projects, and then high traffic density, 200 projects. So this is the government focus. Then upgradation of the railway tracks and bridges to upgrade the speed or augmentation of the speed up to 160 or 200 kmph. So for that, already upgradation of the traction system is going on, and the new traction substation of 2 into 25 kV systems are already under execution. Then high speed, there's already a Mumbai-Ahmedabad high-speed project is ongoing, and there's a further plan of another project at Delhi-Varanasi. Then semi-high speed in the same way through Nandapuram to Kasaragod, then Ahmedabad, Rajkot, Pune, Nasik. Similarly, RRTS project, this Delhi Meerut is already on the verge of completion. And then new Delhi-Alwar corridor and Delhi-Panipat corridor upcoming projects. Similarly, suburban railway network, that is Bangalore through this Karnataka rail infrastructure, K-Ride. And then in Gujarat also, G-Ride, in the same way in Kerala also. So suburban railway network is also to be upgraded and to be constructed. Then for the accident prevention, that TCAS, Train Collision Avoidance System, which has been already this around 2,000 kilometer already implemented, and there's a target for further 36,000 kilometer. This coverage has to be installed. And similarly, automatic block signaling. Then the station modernization is ongoing on. And for the maintenance of the track, now it has been given to the private players. Then railways is just inviting a lot of bids for the suppliers or for the track maintenance agencies who can deploy their own machines like blast cleaning machines, dynamic track stabilizer, blast regulating machines, and track tamping machines. So these projects shall be given for the 15 years for the maintenance. So the opportunity is immense in the railway sector, and railway sector is doing very well. but we have to develop the capability, and we have to see the challenges. So also the competition is too high, and there are so many challenges for the civil construction companies or the electrification companies. But these things, before I would like to just my co-panelist, I will just stop here, and I will invite my co-panelist. So they will speak about the challenges and all these things. So now I will invite Mr. V. Narayan. So he will give his presentation.
Good morning, everybody. कौन सा करना है? किस नाम से था? किस नाम से? अच्छा इसमें क्या करें, रिपेयर करें? क्या कर रहे हैं ये? कुछ हो गया प्रॉब्लम इसमें, ये लगा दो इसमें। जी Hello everybody. So we are now in the track, and I will cover the one important part of the track, that is switches and crossings. And switches and crossings are the most vital component of every track system, because our safety, our speed potential depend upon the switches and crossings. Of course, these are there have been many developments in the switch and crossing, which I have incorporated it. First is that now we are making the switches with the tangential entry angle. Tangential means just no angle. Switch and entry angle is the angle between the tongue rail gauge face and the switch rail gauge face, and if it is 0, then you will not feel any jerk, but you do feel jerk because there is some angle. But from the earlier past, when it was 1 minute or 1.5 minutes, it has now gone down to less than 10 minutes. We are using the switches entry angle less than 10 minutes, 10 seconds. Second development is that we are using thick wave switches. Earlier switches were very thin, and they used to got worn down early. Now we are using thick wave switches which are very stable, and switches with back drive. You may see the drawing. Switches with a back drive, so that housing is proper and controlled, because housing is the one thing which is very much related with the safety. Then if you go through the railway line, in the train journey, you must have felt the jerk, because there used to be a turnout, and in turnouts there used to be some fish-plated joints. Now we have gone past the fish-plated joints in the turnouts, and we have gone for weldable crossings. In fact, now turnouts, switches and crossings, they both are weldable. And CWR, which is continuous welded rail, it is going through the turnouts now. Next is that we are using the double clothoid geometry over the turnout, that is Earlier they used to be straight and then curve used to start, but now, as you can see from the drawing, the smooth transition, there is one curve which starts from the shock joint and it ends in the circular curve of the turnout. And of course, there is switch nose crossing for the higher speed that we are using. Now, what are the effects of these developments? First is that introduction of higher speed over the diverging routes. Earlier, over the loop lines, there used to be speed of only 15 kmph, now which has been increased to 30 kmph, and now in DFCCIL, this speed has increased to 55 kmph. More is the speed, less will be the detention of the train. And by using the specialized turnout, we can achieve the speed up to 230 kmph over the diverging route. So it is as good as the main line. Now, secondly is that the riding is very, very good now. Earlier we used to feel that while traveling in the train, we used to feel that turnout ke station aane wala hai, turnout aa gaya hai. Because they used to be on plane and our rail used to be canted 1 in 20. Now we are providing the canted turnouts. Continuation of CWR through switch and crossing is another thing which I have already discussed. It has reduced the impact. Dynamic augment has been reduced. Noise and vibrations have been reduced. So it is a major development and it is going to be introduced in Indian Railway also. In DFCCIL, you will see that there will be no joint in the rail for 40 to 45 kilometers. So almost all the area is welded. Now, and this has improved the stability as well as the riding characteristics. Elastic fastening systems has also been improved. Canted switches and crossings for uniformity in rail wheel interaction, and now we are having the longer life of turnouts because of the welding, no joints and canted. Now because time is very much limited, so I will just go through the advanced technology which are coming in this field, way forward and recent developments. High speed turnouts, which I have already discussed, that it has the speed potential of 230 kmph on the diverging route. And you can see from the drawing, the crossing is movable. It is swing nose crossing, so that there is lesser discontinuity over the track. So these are the orders of the advancement. Second is that high performance switch system with various monitoring devices are being developed, which will increase the speed potential over the turnouts. You can see that various sensors have been installed over the turnouts. Another development which has come recently is that turnouts used to be laid in parts, switches separately, crossing separately. Now these turnouts are being assembled at separate place, and these are transported on the inclined tilting wagon, and these are laid in one block. So the quality of laying is very, very good, and it is being followed in many countries, and I think it will be followed in India also. Then now we are going for the advanced turnouts, but we have to go for the monitoring as well as maintenance of these turnouts. This is very, very necessary because these require the system of monitoring advancement. And first thing which I want to say is that we should visualize these turnouts as one piece. What happens? We monitor switches separately, crossing separately, lead curve separately, but our system should be such that we should monitor these devices, these turnout, switch and crossing as one piece. Then only the turnout speed potential can be restored. There are many recent developments in the monitoring and upkeep of these turnouts. First is that we have gone ahead of the manual measurements. Now methods are that which takes the 3D measurement of the profile. 3D measurement of the crossing nose, as you can see from the drawing, of the, and also wheel transition point. How wheel is moving over the turnout, that also can be taken out, and any correction on this to reduce the impact can be done. So we are monitoring we can monitor these turnouts by the 3D monitoring. It is another device, automated measurement trolley, which goes over the turnout and measures every point and scans it, and then uses the software to find out the health of the turnouts. Then now drones are everywhere, and because we cannot do the measurement while the train operation is there, so drone provides the solution in that aspect. We, in first sketch, you can see that we identify the various points on the turnout, and these points are identified throughout the turnout, and drone measures those points. These points are taken, these readings are taken through the software, and the various changes which occurs, these are detected by the software. So no need to go to the site. Drone will take every reading and it will detect the changes, whatever has happened in the recent past. So this was my presentation on the recent development of the turnouts. Thank you.
Yeah, so Mr. V. Narayan, he has given a wonderful insight about the development in the crossing and switches. So now I'll invite Mr. Guldar Miglani to present.
So good evening, good afternoon, friends, my colleagues on the dais and the conference room. My job is much easier because Mr. V. Narayan talked about the benefits of turnouts and switches. I'm a technology provider actually, so I'll not talk about the benefits. Benefits are done. I'll talk about the products, what we do. So I'll just give you a brief about Vossloh. Vossloh is a $1.2 billion company manufacturing fastening, turnouts, switches, and point machines. And we also have a rail services. So we have 3 divisions globally, headquarters in Germany and France. We are in India for last 25 years. These are the 3 divisions. On the left-hand side is fastening. On the middle side, we have crossings. On the right-hand side, we do a life cycle where we do a grinding and the rail services for the railways. We have products and solutions for all the segments: mainline, heavy haul, high-speed lines, and urban transport. Just go deeper into it. So we are one of the largest manufacturer of fastening system, which is called a modern fastening systems. We make 50 million clamps every year. We have a factory in Poland, Germany, China, and so on. Our clamps are this fastening is being used in India for last 20 years in India. This is just a snapshot of our references. We have been supplying fastening for metros from DMRC phase 1, and we have supplied to 20 metros. And these are the different configurations we have for a ballasted track, ballastless track, and for the UTS market. These are the customized modules. Again, Mr. Veeran talked about switches, turnout, canton turnouts. We all make in-house through our technology from Europe. These are just a brief about, we did a turnout for 507 kilometer per hour, long time back in 2007. We also have for conventional, we also have for high speed, we also have for freight, for tram-based metro. So we have switches, turnout for all the applications, wherever you want to use it. This is just a brief about our Indian operations. As I said, we are a global Indian company. We have 3 manufacturing units, 2 in Bhilai, 1 in Hyderabad, and we also have setting up a factory very shortly for our fastening business. From our Bhilai unit, we supplied welded crossings, CMS crossings, and on the dais, I have all the customers there actually, so all buy my products. In Bhilai, we also make point machines, switch machines, which are IRS also and imported also for metros. In Hyderabad, I make turnouts. Fastening, we have decided the location and soon we will be manufacturing fastening locally also. These are the references from DMRC phase 1, where we have supplied our turnouts and the point machines. This is just a glimpse of, this is a slide of Indian Railways, how they are now. So the evolution has happened in the rolling stock, signaling, wagons, everything. I think track is left. So now a lot of emphasis on track modernization, because if you want to run a Vande Bharat at 160 or 200, you need tracks for it, and you need track modernization. So Railway has a clear roadmap where they want to go for removing of fish-plated joints, modern track structure, modern fastening, doing WCMS, canton turnouts. So all these technologies are the future for Indian Railways if they want to run trains at a higher speed. Without that, they cannot run. And on the right-hand side, if you see, we play in all the aspects. So on the bottom, you see, we do WCMS, we do thick web switches, we do LWRs, we do level crossings and bridges. We also do, we don't make sleepers, but we do fastening actually. And the last is inspection and monitoring, which is also a part of our portfolio. This is just a snapshot that the amount of money Railway is spending on the growth and the budget increase. So there is a 21% increase in the track budget, which is there, which clearly shows that Railway is focusing on track going forward. And because they understand that until the track is modernized, trains cannot move. These are the technologies, as Mr. Veer and I talked about. I'll not go in detail. These are all modern technologies which are now necessity. They are not the vision now, and the Railway has gone for tendering for many technologies going forward. This is our modern fastening system, which we have done trials on Indian Railways. We got a contract from Indian Railways in South Central Railway and East Coast Railway. This is called W30. I think you must have seen a video from Mr. Ashwini Vaishnav holding this product, because he's also convinced that until the fastening is changed, there will be accidents, there will be loosening of the components there. This is just a snapshot of the project, what we do. On the right-hand side, you see the conventional fastening, which is by hammering, and this is the modern fastening, which is a bolted type, and the loosening doesn't happen. And this project is complete actually, so we did more before delivery period. This is my last slide, again, on the life cycle solutions. So besides the products, on the track side, we also do life cycle solutions for providing grinding machines and the services for Indian Railways. Thank you very much.
So thank you, Mr. Miglani. Now I will invite Mr. S.C. Gupta from Larsen & Toubro just to present.
Yeah, good afternoon, everyone. I know time is short, so I will not take much time. What I will cover here, what we as L&T doing and contributing in the modernization of modernization of rail infrastructure by adopting automation and the latest technology available globally. So what this slide shows that we have presence pan-India basis, also globally. What I am covering only of the presence in the rail infrastructure projects. So what we are doing, we are into the all type of rail infra projects. We start from the mainline railways, then high speed, rapid metros, monorail, LRT, dedicated freight corridors, and whatnot, I think. We cover all type of rail projects. What we have done, around 21,000 track kilometer of rail electrification last around 7-8 years, which comes around from 2,500 kilometers in a year, which I mean, it's almost equivalent to what Indian Railway was doing a few years back, put together. So we achieved that much. And we also constructed about 4,600 kilometers of the ballasted track and some 1,360 kilometers of the ballastless track. So these are the figures, but what I'll cover, the way we achieve, how we achieve these figures. There is a technology behind this, there is a thought process behind it that I'll cover in subsequent slides. Yeah, next. So this is again a snapshot, what sort of projects we are making. You can say from left, main line, we are right from bridges to mainline tracks, including the complicated turnout process in the yard, what Mr. Veer Narayan was presenting. Then in the dedicated freight corridor, right from the operation and command center to the construction of the track lines, electrification signaling, and the power supply substations. Then in international projects, we are making the tunnels, tracks, the all subsystems of the metros. I mean, you can say traction, power supply, AFC, the platform screen doors, and OCC, all. Like, I mean, you can say right from start to end and start to finish commissioning of the metros. Similarly, light rail and monorail, we completed such some projects in the Mauritius and Dhaka and Riyadh. Yeah. So this is the technology what I was talking about. So we brought the mechanization and automation in the construction process. These technologies are available globally, but we brought the technology here. We indigenously fabricated and made those machines. So what machines we are using in construction, these tracks and the traction technology is all made in India. Some of our own involvement, some we have imported the technologies. Right, you can see from the left side top corner, the track slab laying car. This is Japanese technology, which all we built up in India. Now we are using this in construction of the high-speed track from the Ahmedabad to Mumbai. And you can say the middle one, the semi-high-speed track mechanized laying car, this is a port technology of the Europe. This also we have completely adapted indigenously. All machines we have made within India, and we are doing this construction of this project in a fully automation way. I'll discuss in detail in the next slides. The type of automation which we adapted in construction of the precast slabs and laying of the tracks, which is, I mean, not only first time in India, some of them you can find very few countries globally. Similar, I mean, I'm not going to detail that right bottom corner, we have used full automation in the OHE wiring, using the wiring trains. Then left bottom corner, the normal track link machines is called NTC, new track link machines. These are the machines which normally adapted abroad, but now being first time adapted in dedicated freight corridor in India. Now probably Indian Railway will also use when they are going for the achieving target like 21 kilometer a day or 22 kilometer a day, what my friend was talking, which appears to be a big target, but these targets are not possible without adopting these sort of methods. So this is some of the precast technology. You can say left bottom corner and the right bottom corner. These are the slab factories which we have installed here. One is for the high-speed, making the slab, Japanese slab for high-speed track, and another is for the port technology, the European slab for the rapid metro. The details which I can describe here, these factories are fully automated. Automation level means right from the placement of reinforcement. Those who understand this is a very common thing, most of us understand the civil construction. Right from placement of the reinforcement, then assessing how much concrete is required in the particular mold. The machine automatically assesses the concrete, goes to the batching plant, bring concrete, put in particular that mold, and then do vibration. The slabs are taken out automatically, and the dimensions are measured automatically. Then subsequently laying happens. So this is completely automated. This is first time in India. The good part of that, this entire technology we have inbuilt, indigenously developed. Though we took the idea from the foreign projects, but we could able to adapt it fully indigenously. So that is a good part of it. And this is the, one of the, let us say, state-of-art type of the factories which you established for the construction of high-speed tracks as well as the rapid metro tracks. Yeah, I think that's all. Thank you.
So thank you, Mr. Gupta, giving insightful about the new construction technologies being used by the Larsen & Toubro. So now I will invite Mr. Shonak Mitra to give his presentation.
So good afternoon, everyone, and I'll try to keep it very short. I take inspiration from few of the terminologies which was used time and again from the morning sessions. One is safety, one was reliability, one was technology, sustainability, and one of the challenges which was highlighted is availability of skilled workforce. So when we talk about the different systems which are being used in the railway sector, it also translates to the way they are constructed. Right? And the whole intent of the session over the next 5 minutes is to try to address how we can ensure safety and productivity while we do the construction at job sites. The information is a copy with pride from the RLDA website. So the way we are transforming our railway sector, lot of developments are happening, are also planned. And one of the key elements is also the railway stations that are being developed, the redevelopment of railway stations. We see around more than 100 railway stations are being developed or redeveloped in this regard, and the way they are trying to be the economic urban city centers, they actually clearly align with the country's vision of urbanization and sustainability. We want to give the best solutions, we want to give the best amenities while we adopt the state-of-the-art construction technologies. Now, when we talk about the stations or, for example, railway as a segment, these are categorized as most important building structures as per even the National Building Code or other construction standards, which implies that whatever components that are being used and that are critical for the functionality of the railway infrastructure, they have to sustain under all conditions. And that includes also the conditions of earthquakes. Now, when we see the photos, the way we also want to modernize the railway buildings, even the metro stations, they have a lot of elements which are primarily structural. They carry the load. And then there are non-structural elements which are basically our supporting the utilities or building operations, which includes our cable trays, our utilities, the HVACs. We have spoken about the systems, but how they are also maintained. That's by creating certain support systems and which are getting fixed to the existing structures. Now, one of the biggest problems that we face is we are not super planned in the way we work, and that's where the relevant people are onboarded also at a very later stage. I mean, we know the utilities have to come in the building, but we don't onboard the right person so that we can plan the things well in advance. And that's where it leads to a concept called post-install, wherein we have to actually work on some existing structures. The building is done, the concreting is done, and then we have to start working. And this is a technology which has been well adopted for the last 25, 30 years in India, more like around 80 or a little more than 100 years globally, but we still had this gamut of, I would say, a place of uncertainty because we did not have a standard for this in our country. And it is not just about the stations. You walk into a tunnel and the level of utility starting from the tunnel ventilation fans, the cable tray supports, the railings, handrails, everything, these are being supported with the help of these post-installed anchors. Sir has spoken about the fastening technology specific to rail tracks, but then these are the things which also keep your railway infrastructure going. So, I mean, there is just to build up the confidence, there is also a standard which has been developed on this because it was a gray area. I was fortunate to be part of the 4 people who developed the standard under the Bureau of Indian Standards, and now we can go ahead with this in a more confident manner. At the same time, it is important that while we can design and we can do a lot of good product selection, there also has to be a decent workmanship at job site. And currently what we see is these anchors are used in numbers of some 10,000s, 50,000s, depending on the stretch. And these are not, it is not possible to manually also monitor their right installation. And what happens is we end up using the right anchors, very good products, but in a very faulty manner, which leads to a lot of failure. I mean, there has been failures of the airport. I mean, the canopies in Delhi airport followed by a couple of more. There has been a failure of the railing in one of the institute buildings, which has caused casualty of quite a few students. This was not because of poor work, I would say the poor products, but it was more about the workmanship. So there are certain systems how we can really avoid this, and maybe, I'm not sure if the sound is working. Yeah, it is. Maybe this gives you a better insight about why this is important, and if we are not able to do the right installation, what actually happens. A good product can actually fail. And when you are working on a structure, existing structure, which is also supposed to transfer the load, you can also in the process damage it. If the installation is not right, maybe the right load transfer will also not happen. And honestly, we cannot monitor some 50,000 anchors, 50,000 fixing points by going at each and every location, which is not a very realistic solution. So somewhere we have to depend on the workman who is doing, and the problem statement that we stated is we have a lack of skilled labor. If you can fix this, it's highly automated and you don't need a very strict monitoring, because you now know it's a visual way of detecting whether this has been particularly installed well, and you can 100% document it. So that's the way we go ahead. And another very common thing which we see at job sites is how it is installed with a lot of coordinate system. And these are real-time pictures from job sites. So when we have to really stretch the cords across the job sites, there is a huge time wasted. And we are all working on time-bound projects, and this creates a lot of mess. So it's not just about cordless and getting the good power. This can also be innovated into a cordless system, which gives the same performance, and not just for these little small tools for anchor installations, but for heavy dismantling or even for heavy concrete cutting. So it's basically we are transitioning from, as an industry, from a highly coded system dependent on coded tools to a cordless, and then we are also transitioning to a single platform, which can really help people use the single battery platform for the different tools which work.
Mr. Mitra, one more minute, please.
Yeah, it will be done, sir. So the whole intent is we keep on and while we do so, we also take care of the hazards, not in terms of the structure, but the hazard the dust causes to the people working. And we also know in NCR about a month in the year, we also stop the major construction works because of the air quality index. So with the systems, we also have to ensure that how we can minimize this, because at the end of the day, it also helps increasing the productivity and the way we work at job site. The intent is to make construction better, safer, and this can be few of the ways that we do so. So I think that's it from my side. I went a little quick, but open to questions after this.
So thank you very much.
Thank you, sir. Let's have a huge round of applause, ladies and gentlemen. I now request our esteemed panel to please step forward for a group photograph.